Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. This is the last part of section 7.3, and it's about independent events. So let us consider tossing a coin twice. If you remember, the sample space is four outcomes. You can do a 3 diagram for this experiment. The first coin is HH, and the second coin would be HT. The first coin is HT, sorry. So we have four outcomes, HH, HT, TH, Now we need to discuss something. What is the probability that the second is head, given that the first is head? So we need the second is head, this one. What is the probability of the second is head, given that the first is head? Well, the probability here is half, here is half. So what is the probability here? It's also half. So we are tossing the coin twice. So each time we toss a coin, the probability of obtaining head is half. So if you say the probability of head in the second, given that first head, it would be also half. It would be also the probability that the second is head. So this condition really did not change the probability of the second being a head. When the condition, when the given event, when the condition does not change the probability, then we say that the two events are independent events. So A and B are independent if and only if probability of A given B equals probability of A. So the unconditional probability of A is equal to the conditional probability of A. B as a condition did not change the probability. Also here, if probability of B given A equals probability of B, the unconditional probability of B equals the conditional probability of B. So A did not do anything, did not change the probability. This means that A and B are independent events. So we call A and B independent if one of these two holds. So this means that the occurrence or non-occurrence of one event does not affect the other. Now, what would be the product rule in case of independent events? We know that the product rule in the previous video is equal to probability of A times probability of B given A. But what is the probability of B given A if they are independent? It's equal to probability of B. So probability of A intersection B would be the product of the two probabilities in case of independent events. So if you know that A and B are independent, you use this formula. If you do not know that they are independent, you don't know whether they are independent or not, you use this formula, the original formula. Okay, so this is used only if you know that the two events are independent. And we can also add it here. So we can say that the two events are independent if B probability of A intersection B is probability of A times probability of B. So if you find that probability of A intersection B equals probability of A times probability of B, this also means that A and B are independent. So you can use this as definition of independence. Okay, so we have these three things, three conditions or three. If any one of them satisfied, this means that A and B are independent. And if A and B are independent, then all of these three are correct. A die is rolled and a coin is tossed. So If I ask you what is the sample space, you roll a die and you toss a coin. So you could have one head up to six head or one tail up to six tail. Okay, so you have 12 outcomes. Find the probability of getting a 4 on the die. So he is asking about the probability of 4 and on the coin you get a head. So what is the probability of 4 and H? Well, uh, getting 4 on the die, does it influence getting head on the coin? They do not influence each other. So the probability of and would be just the probability of 4 times the probability of head. So what is the probability of 4? Uh, it is a die. When we roll a die, probability of 4 is 1 over 6. Probability of head is half. So this is the probability of having a 4 and a head. Two balls are drawn, two balls, with replacement. If you remember, we discussed without replacement and with replacement in the previous video. And if you notice, with replacement, when we replace the balls, when we put the ball back, the probability, the second probability does not change. Okay, the probability that, for example, two balls here uh, contains three red and four green. So this is the probability of green, probability of red. This is green and red. The first ball could be green and red. Three red, so 3 over 7 is the probability of red, and 4 over 7 is the probability of green. Now, the experiment is with the replacement. So the second ball, what is the probability that it's green? It's still 4 over 7, and this is 3 over 7. So here you can see that the probability of green given green is equal to probability of green. So getting green in the second is independent from getting green on the first. So are these draws independent? Yes. Explain, because you can say that uh, the result of the first draw does not affect or does not change, you can say does not affect or change the probability of the second event. So probability of the second draw will remain the same. Okay, probability of the second draw is 4 over 7, doesn't without, so they do not influence each other. You can say this. Find the probability of getting a green ball on both draws. Green ball, GG. So in this case, it's 4 over 7 times 4 over 7. Well, the product rule for independent events can be expanded for more than two. Okay. And for other events also, but for independent, it would be easier. A bag contains 3 red marbles, 4 white marbles, 3 black marbles. So the total number is what? 10. Find the probability of getting a red marble on the first draw, a black marble on the second draw, and white marble on the third draw, if the marbles are drawn with the replacement. With the replacement, we need to find the probability of obtaining red and black and white. So it would be the probability of red times black times white because they are independent. Selecting a ball in the first does not affect selecting does not affect the probability of selecting a ball in the second because the experiment is with the replacement. So you can say the probability of red. What is the probability of red? How many red? 3 out of 10 times. The number of balls is fixed. It is with replacement. So probability of B is 3 over 10 and white 4 over 10. And this would be the answer. But for part B without replacement, here the probability is not going to be their products. Here you have to use conditional, okay? So it's probability of R times probability of B given R times probability of W given B and R. So it is not because they are not independent in this case. Probability of R is 3 over 10. But now black in the second would be 3 over 9. White on the third would be 3 over 8. Okay, so that's the probability. Uh, how many whites? 4. Yeah, it did not change. The number of white balls is 4, and it remains the same because we selected red in the first and black in the second, so the number is fixed of the colored balls, but the number of balls is decreasing 9, 10, 9, 8, because the experiment is without replacement. Any ball, any marble you choose, you keep it with you. A coin is tossed 4 times. When you toss a coin 4 times, how many elements in the sample space? If you remember, we said 2 times 4, which is 16. And one of the possibilities would be head, 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 and so on. No heads occur. No heads, this is the probability of T, 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 T. And this is 1 over 16 because the number is 16. At least one head is obtained. When he say at least one head, what does it mean? It means one head or two heads or three heads or four heads. So everything except what? Except four tails, zero head. So the probability of at least one head is 1 minus probability of t, 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 t. So it's 1 minus 1 over 16. And that's important to pay attention to at least one head. You can also find this probability in A by saying that it is 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2, because selecting or getting ahead in each time is independent from the other. So you are multiplying 4 times, or just it's 1 over 16. A box contains 3 red balls, 2 white balls, 5 black balls. The total number is 10. 2 balls are drawn at random from the box with the replacement of the first before the second is drawn. So we replace it, we put it back. What is the probability of getting a red ball on the first and a white ball on the second? So probability of red and white would be probability of red times probability of white because they are independent from each other. Probability of red is 3 over 10. Probability of white is 2 over 10. Okay. Because the experiment is with replacement. 3 red, 2 white. Red and white. Yes. Answer the question in part A. If the first ball is not replaced, okay. So then the probability will be probability of R and W. It would be probability of R would be 3 over 10, but now probability of white would be 2 over 9. And 2 over 9 is not probability of white, it's probability of white given the first ball is red. Are the events in part A and B independent? In part B, they are not independent. In part A, they are independent. And the reason, because as we said exactly here, because the result of the first row does not affect the probability of the second row. So whenever it is with replacement, they would be independent. To test its shotgun shells, a company fires 5 of them. So what is the probability that all 5 will fire properly if 5% of the company's shells are actually defective? So what is the probability that it fires properly? 5% defective, so 95%. Okay. So we need the probability that all 5 fire properly. Okay. This means that probability of the first one fires properly and the second one and the third one and fires properly or not is really independent from one shot to the second to the third. They are independent of each other each time. So you can multiply the 5 together. Probability that the first time fires properly is 0.95 times 0.95 times 9.5. How many times? 5 times. 23% of the cars owned by a car rental firm have some defect. So probability of defective 0.23. What's the probability that of 3 cars selected at random, none has a defect? We are selecting 3 cars and we need the probability that none has a defect, none defects. Okay, so what is the probability non-defect? It is probability that the first non-defect and the second non-defect and the third non-defect, and we are selecting at random 3 cars. Really it's independent from each other, the first selection being defect or not, it will not affect the second selection. So we can say probability, the first is non-defect. Now, if the probability of defective is 0.23, so 1 minus 0.23 is 0.77, and this is the probability of non-defects each time. So 0.77 times 0.77 times 0.77, 3 times. At least one has a defect. What is the meaning of this? At least one has a defect. So 1 or 2 or 3, so it's everything except and all are non-defect. So it is 1 minus the previous probability. Pay attention to at least. An unprepared student must take a 7-question multiple choice test that has 5 possible answer per question. 5 answers, so 5 possibilities, A, B, C, D, E. If the student can eliminate 2 of the possible answers on the first 3 questions, so he can eliminate 2 on the first 3 questions, but not on the last 4. If she guesses on every question, she guesses, what is the probability that she will answer every question correctly? How many questions are there? 7 questions. So the probability that all correct would be the probability that the first is correct and the second and the third. So it's product rule, and all are independent. Being correct in the first question will not affect being correct in the second question. So what is the probability that she is correct in the first question? In the first question, she has 5 possibilities, but she can eliminate 2. So she still have 3 possible answers, and she has to guess. So the probability that she gets it correct is 1 over 3. Times 1 over 3 times 1 over 3 for how many questions? 3 questions. But for the last 4 questions, she has to choose 1 out of 5. So the probability that she is correct would be 1 over 5. In each question, we have 4 questions. So you can multiply this and find the answer. You will find that the answer is 1 over 16,875. Very small uh, probability that she gets all of answers correct. What is the probability that she will answer every question incorrectly? So all incorrect. Okay. Now, uh, how would she answer all the questions incorrect? What is the probability that she answers the first question incorrect? She has 3 choices because she can eliminate 2. She can eliminate 2. So the probability that she answers the first question incorrect is 2 over 3. And this would happen for the 3 first questions. The probability that she answers the 4th question incorrect is 4 over 5. Probability of answering correct is 1 over 5. Not correct, 4 over 5. And you can find this probability. You can multiply these numbers. So this is the probability. Now, what is the probability that she will answer at least 1 correctly? At least 1 correct. Think of this. At least 1 correct. Means 1 correct or 2 or 3 or 4 or 5 or 6 or 7. So what is left? None is correct. So 1 minus 2048 over 16875. This would be the probability that at least 1 question is correct. Thank you very much. I hope you enjoyed probabilities.